All right, we have one example left from the 27.3 notes. This one's pretty straightforward. I would advise you to try the whole thing right now before you go ahead and listen. So we're going to break it apart. Part A is find the asymptotes. Let's start with vertical asymptotes. So for a vertical asymptote, that's up and down, that's an x value. Let's look at this function. What x can I not have? I can plug any x in the numerator. I can't have any x in the denominator. So what I've done is I've set the denominator equal to 0 to figure out what x would have to be to make the bottom 0. So I solve for x. I get x equals 3.5. So my vertical asymptote, x equals 3.5. Since we're graphing and we're going to be thinking decimals, you can leave it as a decimal. While we're at it, why don't we just go ahead and graph that? So let's graph a vertical line at 3.5. Here we go. Again, I did that because that is the x value that I can't have. So there's going to be no values there. There's going to be an asymptote. Now, I forgot to mention before we started, but does this look like the parent function? No. It's not just going to be left, right, stretch, shrink. Not a transformation because there's an x on top and an x on bottom. So in order to do the horizontal asymptote here, we're going to have to figure out what happens, what number am I approaching. So for example, am I getting close to 10? Am I getting close to 5? What is it getting close to on the far direction? So when x is like 500 and x is negative 500. So grab your calculator, put in a really large number for x and see what it's getting close to. Put in that number with a negative and see if it's approaching the same thing. So when I plugged in 300, I got 1.526. When I plugged in negative 300 on the far side, so way out here, I'm getting close to the number about 1.47. So it's really close to 1.5. So I'm going to put 1.5 is what it's approaching in the y direction. That's the height we're getting close to. So let me move this to 1.5. All right, let's find x and y intercepts. You know what to do. Plug in a 0 for y, then plug in a 0 for x. You can show as much work as you need to, and I'll put my answers up. Okay, so here's what I got from my answers. My x-intercept is negative 5/3. So that's a little over 1. So negative 5/3 is about there. My y-intercept is negative 5/7, so less than 1. So I have enough information over here to connect these. I know they're going to be inside those asymptotes. Something like that. And I know the other one's probably going to be over here somewhere, but it might be good to just plug in a point. So go ahead and take a second, plug in, I don't know, let's plug in 7 for x and see what we get. When I plugged in 7, I got 3.7. So 7. And you really don't need much more information. I'll just take that. And there's my graph. Okay, so we've done A, the asymptotes, B, the intercepts, C, sketch the graph. We've got that. D, identify domain and range. We haven't done that yet, but let's go ahead and do that. Domain. So let's think about, let me make a line here. What x values can I have? So I definitely have a value here. I definitely have values here. What values can I not have for x? This one right here, this asymptote. So that was an x value of 3.5. So my domain is, we'll write it a couple ways. First we'll say all real numbers and x cannot be 3.5. Now if I say to write it in interval notation, that's going to look like this. Okay, so interval notation is going to be highest and lowest value. So my lowest value is negative infinity up to 3.5. Any other values I can have for x? Yeah, so we're going to do what's called the union, which is just a u basically. And then we can have more values. We can have x's from 3.5 to infinity. And we should use parentheses, not brackets, because we don't include 3.5 and we don't include infinity. Let's talk about the range. What are the y values we can have? Well, it's going down forever. It's going up. Oh, we don't have a value there. And then after that, it's going to keep going up. So there's only this value is the only one we can't have. So it's going to look similar to your domain. It's going to be, sometimes we write all real numbers. You guys know the symbol for all real numbers. All real numbers, except y cannot be, what y value can't I have? Can't have a height of 1.5. Or I don't have a value of 1.5. If I don't tell you what notation to write, you can write it like that. If I say interval, you have to write it like an interval. If I say set, you got to write set. The other one is inequality, so let's do inequality. Negative infinity, less than y, less than 1.5. That takes care of all these low values up to 1.5. And we also have, we could just do union again. And then we have 1.5 up to infinity. So there's the domain and range. Anytime you're doing these, check and see if your original function, your original graph, looks like a transformation. Can I just go left, right, stretch, shrink, or no? The answer is no if there's an x at the top and an x at the bottom. In that case, you have to do these 4 things, plot those 4 things, maybe plot 1 or 2 extra points if that's helpful, and then you've got your graph. All right, so go ahead and try your homework. Make sure I see specific points and make sure it's not just a computer screen of what you get. I should see probably these 4 items every time listed out and shown in the graph.